All right, so we're going to be doing double replacement, okay? And on this worksheet, I'm going to basically incorporate 5 things for each one of these reactions, all right? And so we're going to go through the first one together, but just quick reminder, your double replacement one, what did we call it? A double date gone wrong. Okay? And so if you look at our instructions, it says 1, predict the products, meaning switch your negative ions, crisscross charges. You're going to see me switch the positive ones, okay? Then number 2, you're going to add in your states of matter. So we're going to look at our solubility rules, and this helps you out right here. It tells you if it's soluble, that means you're going to put an AQ next to it. If it is insoluble, you're going to put an S next to it. Yes? All good? Cool. All right. What do we also call these guys, the solid ones? Starts with a P. That's it. Okay, good. So a precipitate. All right, cool. And then finally, after that, we are going to balance. Now, before I move us into the first example, if you can flip your page over and look at 11 and 12 with me, this is going to be the only extra thing that we're going to add to these problems. Okay? So, I was really tired last night. That's why these didn't end up on the front. I'm sorry. I don't know why I did it like this. So what you're going to do is you're going to do these 2 steps now also for all 10 of your reactions that you're going to run through. Okay? The first one says if I use 5 grams of each of the reactants, decide which one is a limiting reactant. So you're going to do a limiting reactant problem. Then the next one says you're going to calculate how many grams of the precipitate. So you're looking at what? The solid one or the aqueous one? The solid, okay? And so when you go to calculate, make sure you're going all the way to the solid ones, okay? Now, I'm going to shorten this up for you if you guys want a little bit. Cross out the word grams. On number 11, cross out the word grams. Not on 12. You have to do grams on 12. Grams from number 11. Change that word to moles. And so that your numbers aren't outrageously huge, go ahead and cross out the 5, and we're going to change that to be 0.500 moles. Okay? So, sig figs, what should all your answers pretty much be? 3. Trailing zeros count, leading zeros never count. All right. Okay. So, that's what we're going to be doing once we've balanced it and done all that other stuff, okay? So we'll come back to that in a second. All right. But make sure you made that change or else you're going to be working harder than everybody else. Okay. All right. So back on number 1, we've got lithium sulfide and silver nitrate, okay? So the first thing says to predict your products. Okay, so I told you guys I'm going to be switching the positive ones, but you could switch your negative ones. And so doing that, I'm going to switch lithium and silver. So I'm going to now have silver and sulfur. Okay, looking at the charges, because we got to read crisscross charges. What is the charge on silver? Yeah, that's what I was expecting. All right, so look at your, it is not 6. Look at your periodic table, or actually no, just look up here. All right, aluminum. Aluminum is in group 13, so what's its charge?
Wait, no, it's 2. It's 2.
It's not 2 either. Okay, aluminum is plus 3. Are we all clear? Okay, so we go 3, 2, 1. Okay? Okay, all right, so we go 3, 2, 1. So silver is what? 1. All right, that's the way to do it. Okay, and zinc will be 2, and the other ones. Okay, so but you do need to know this. All right, so silver is going to be a plus 1. What is sulfur going to be? He's underneath oxygen. It's going to be a minus 2. So if we crisscross these, the 2 comes across. We have Ag2S. Right? All good so far? Cool. All right, and then our other product that we're going to make is we will have lithium mixed with nitrate. So lithium is in group 1, so what's its charge? He's a plus 1, and nitrate is a, where can you look for nitrate? Yep, polyatomics on the inside of your periodic table. So go ahead and look there. It's a -1. Good. So crisscross those. Are there any subscripts we need to add to this one? No, we're good. Okay, cool. So we got our products. Now we're going to add in our states of matter. So we need to look up our solubility rules, okay? And I want you to take a look at your solubility rule list real quick. Are they mostly negative things or are they mostly positive things? Negative things. So you're going to be paying attention to the second thing listed in all of your compounds for this whole worksheet. When you're using your solubility rules, that's who you pay attention to. So if you guys give me a sec. All right, so we're going to look on our solubility rules list. Just before we keep going, you should at the top, somebody from second period should have wrote this for you if you're using one of the class sets ones. If you don't have that, you're more than welcome to write it on there. You're going to need that for one of the problems today. So group 1, basically anybody in group 1, if they are involved, that makes it a soluble compound, okay? It's one of your solubility rules that's just not listed on here. All right, all good on that? Okay, cool, awesome. So let's look for the ones that we've got. So we've got sulfur, or sulfide, okay? So we're gonna look all the way at the bottom of the list. So we notice that sulfur, or sulfides, sorry, are insoluble unless they're with ammonium or one of your alkali metals, which is all group 1 things, or calcium, strontium, or barium.
No.
Is silver any of those? No. So what is the sulfide for this one? He's going to be solid. Good. All right, so I'm going to pull that out of the way. We are going to add in an S right here. Okay? So there's my state of matter. Okay. So just to verify, to make sure we didn't make 2 solids, because that would just be awkward and not a good reaction. Let's look up the nitrate. Nitrate is up towards the top of the list. Okay, here's nitrate right here. Nitrates are soluble unless, and there's no exceptions. So when you see a nitrate, those guys automatically get what symbol? AQ, good. Okay. All right, so now we're on number 3, which is balance them. Okay, so here, let me change colors so we have another color up here. That's not annoying. All right, we can list out all these in the center. I kind of gave you guys enough room to at least do the listing kind of balancing. If you're going to need another sheet of paper to do the box method, then you may use that. All right, but lithium, sulfur, silver, and then this is one of those examples where you're going to want to keep your polyatomics together. That way you don't overcomplicate it, okay? I'm going to zoom in on this just a little bit more so you can see it. All right, so when we go to count these, lithium on the left-hand side, there are 2. And on the right-hand side, there is only 1. On the left-hand side for sulfur, there is only 1. And on the right-hand side, there's only 1. For silver, on the left-hand side, there is 1. On the right-hand side, there are 2. And on the left-hand side, there's only 1 nitrate. On the right-hand side, there is only 1 as well. Okay? All right, so looking through this, I'm just going to go through from top to bottom. Lithium, I'm going to try to fix that one first. So I'm going to come over here to the lithium nitrate, and I'm going to throw a 2 in front of it. And then I'm going to recount. So I have a 2 in front of my lithium nitrate. Recount, I now have 2 lithiums, and I have 2 nitrates. Continuing down my list, I notice the silvers are unbalanced, so I'm going to come over to the left-hand side, the silver nitrate. I'm going to put a 2 in front of that one, and I'm going to recount. Now I have 2 silvers and 2 nitrates, and now I'm balanced. So it's a 1-2, 1-2 mole ratio. Okay, we doing good so far? I'll give you guys a second. All right, so now we're gonna look at, you guys have a blank side off to the right, okay? I'm just gonna use this blank space over here, okay? Move this over. Ooh, actually, I have to leave it right there, sorry. Okay, push that all up to the side. All right, so if you guys remember, we're going to be answering these questions now. So we're going to say, if I have 0.5 moles of each of the reactants, decide which is the limiting reactant, and then determine how many grams of the precipitate we're going to have, okay? So we're going to set up 2 railroad tracks to do a limiting reactant. So you can start off at the top of the page if you want. Label my number 1. I'm going to go ahead and give myself 0.500 moles. Okay, and then I'm going to pick one of my limiting reactants. I'm sorry, not limiting reactants. One of my reactants, which is lithium sulfide. And set up that railroad track ready to go. And I'm going to start another railroad track. I'm going to have 0.500 moles of silver nitrate and have that one ready to go. Okay. All right. Just going to give myself some room here. All right. So we are already in Mole Town. So what are we going to automatically go across?
Mole bridge.
Yes, the mole bridge. So this is the mole bridge step. So I'm going to go, where do I get that information from? The coefficient. So if we zoom in here, my lithium sulfide has what? 1. Which product am I going to change into?
Either one.
You could technically do either one. However, what is the second part of this question asking for? The amount of the precipitate. So which one should I pick, the solid or the aqueous? The solid one, the precipitate, okay? So we're going to do that. Oops, did not mean to zoom out. Okay, all right, so we're going to put in the 1 mole of the lithium sulfide. And we're going to cross the bridge. And we're going to go 1 mole of silver sulfide. Because this is the solid one, all right? That's the whole point of picking it, so that you don't have to do extra work later, okay? Now, you could choose to just figure out your limiting reactant from right here, okay? Or the way we've been doing it, we take it all the way to grams, okay? And then you automatically have your answer and you're done, okay? So I'm going to go all the way to grams. I know that 1 mole of silver sulfide is equal to its what? What would go on top? The what? The molar mass. All right, and to help you out, I got it right here. So I'm going to add 2 silvers and 1 sulfur together, and you get 247.802 grams. Okay. So I have 0.5. I have 0.5 times 1 times 247.802 divided by 1 divided by 1. So technically, do we have to put any of those ones in there? No. All right. So when you multiply it, go ahead and shout out what you get. What'd you get? Good. 123.901. I'm gonna give the full answer for now. We'll round down to our sig figs in a minute. All right. So 123.901. We're gonna do the same thing with this bottom railroad track, right? So we're gonna start with our reactant. We know that its coefficient for again silver nitrate right there. It's gonna be a 2, right? And we're gonna relate it to the silver sulfide again, right? You got to compare the same thing. So, sorry. So I'm gonna have 2 moles of this silver nitrate. We're gonna cross the bridge into moles of silver sulfide again. So basically, what you can rely on is that the ending part is gonna look the same. Right? So you only have to find the molar mass once. You're welcome. Okay. All right. So when we get that typed in, what are we getting?
61.9.
Good. 61.95. I got 5.1. Did you get 5.0?
No, I got 505. Incorrect.
Okay, so I rounded up. That's what it was. All right, we're good. Okay, so out of these 2, which is the only one that's possible? The 61.951. All right, so the way you're going to record your answer is you're going to tell me who your limiting reactant is. Who is my limiting reactant in this case?
Silver nitrate.
Good. Silver nitrate. Then I'm going to say how much is possible. So 61.951 of the silver sulfide. And then I want you to give me one more answer, and that would be with the correct number of sig figs. Oops. Should be 62.0 grams. Okay? And that's what I'm going to be asking for. So, did I tell you the due date on this yet?
Nope.
Oh, tomorrow. No problem. All right, so make sure you put on the top of your paper, due Friday. We will have a little bit of time to work on it tomorrow. Okay, so I recommend make sure walking into class tomorrow you have at least half to 3/4 done. That's what I recommend, because the rest of the time I need for a lab. Okay? Okay, all right.